Hello friends, welcome to the second tutorial of K-mean clustering algorithm. In the first tutorial we studied the basics of K-mean clustering algorithm and we clustered a one-dimensional space. So we were able to cluster this one-dimensional feature space with a few data points into two parts. Now in this video we'll talk about clustering a two-dimensional space. So if you have not watched my previous video, I highly recommend that you do that first so that the things becomes more clearer. Although I'll be solving this numerical also step by step with all the steps in the algorithm. So the problem that we have in hand is I have this data set with these individuals having values for variable 1 and variable 2 given in this table. So I can safely plot variable 1 versus variable 2 on a two-dimensional feature space. Now step number 1 is to decide how many clusters do we need. So let us say I need 2 clusters for this feature space for the data points in this feature space. So I'll say my K is 2. And step number 2 is to decide centroids, is to choose random centroids. Please understand, the choice of centroids is entirely up to you. Once you decide that you would cluster them into two parts, you need to select 2 centroids. You could select any 2 random centroids at any location in this feature space, but I recommend selecting centroids from the points which have some data point on it too, because it will make the mathematical calculations easier. Because if let us say I select my first centroid to be here, 1 1, so this is my first centroid, and I select my next centroid to be at 5 7, so this is the point 5 7, this is my second centroid. So the distance of this data point from this centroid will be 0. So that mathematical calculation will be eliminated, because we need to find the distance of all the data points from the centroid during a calculation. So at least one calculation will be easier. The distance of this data point from this centroid will be 0. Now once you have selected 2 centroids, they could be random. In this case we have selected 1 1 and 5 7. The next point is super important. Then you need to find Euclidean distance of each data point to the centroid. So what I'll do is I'll make a table here, and in that table we could say this is the individual data point, and this could be the distance, which is Euclidean distance from centroid 1, and distance Euclidean from centroid 2. So we'll start calculating the Euclidean distance of all the data points from the centroid using this formula. Now in this formula, xi and xj are the observed data points. For example, all these points 1 1 1.5 2, they are to be substituted here, and mi and mj, which is the mean or the centroid. So first we need to calculate the distance of all the data points by substituting mi and mj to be equivalent to 1 1 and then 5 0. So let's talk about individual 1 which is 1 1. So how far is this data point located from the centroid 1 1? Centroid 1 is of course at 1 comma 1 and centroid 2 is at 5 comma 7. So the distance of this data point from the centroid 1, which is 1 1, is 0, and the distance of this data point from this centroid can be calculated as 1 minus five square plus 1 minus 7 square under root, and this becomes now under root of 52 is 7.21. So I'll say this distance is 7.21. Now what do you infer out of these two distances? We'll say that the data point 1 is closer to centroid 1 and is far away from centroid 2. That is why we'll say that the individual data point 1 falls into the cluster 1. So what we'll do is we'll make two clusters, K1 and K2. K1 is the cluster with centroid 1 at 1 1, and K2 is the cluster with centroid 2 at 0.57. So 1 falls into this category. Now once we are clear with this point, we go on to data point number 2, which is 1.5 comma 2. Let's calculate the distance. So it'll be 1.5 minus 1 square plus 2 minus 1 square. So this becomes 1.12. So I'll substitute 1.12. So the distance of this data point from this centroid is 1.12, that is the Euclidean distance, and similarly substituting 1.5 minus 5 whole square plus 2 minus 7 whole square under root is equal to 6.10. So this is 6.10 away from this centroid. So this is pretty far away from this centroid, and this could be written as the distance of point 2 from centroid 1 and distance of point 2 from the centroid 2. So that is how you can calculate all the distances. So 2 is nearer to centroid 1, so I'll put 2 here also. 2 goes into cluster 1, and that's how you need to calculate all the distances. And I have gotten these distances calculated already, so this is I'll simply write down, and point number 4 is 0 distance away from the centroid, so I'll put a 0 here, but it is far, this point is far away from this, so it is 7.21 as we calculated here. And then so you need to calculate the Euclidean distance. Once the Euclidean distance is calculated, now let's check point number 3, individual data point number 3. it's closer to centroid 1, so I'll put it here. 3 goes into cluster 1. 4 is closer to centroid 2, so 4 goes here. 5 is also closer to centroid 2, so 5 also goes here. 6, 7, they all are nearer to centroid 2, so they all go into this. Now this was the first iteration. In the second iteration, which could be our step number 4, in step number 4 what we need to do is we need to obtain new centroids, and new centroids will be the mean of C1 and C2 centroids. So how do you calculate that? The new centroid M1 will be 1 by 3 of the data points. Let's talk about the data. 1, 2 and 3 are the participants' data points of cluster 1. Cluster 1 consists of 1, 2 and 3. So 3 participants' data points are there, so I divide this by 3, and now the first coordinate of that would be 1, 1.5, 3 added, alright, and the second coordinate of that centroid, new centroid, will be the mean of the second coordinate added up together. So I hope this point is clear, and you get the new mean to be equivalent to 1.83, 2.33. And similarly, to calculate centroid 2 consists of 4 data points, so we are going to add up those data points, coordinates of those data points. So the first coordinate is added first, 5, 3.5, 4.5 and 3.5. 5 plus 3.5 plus 4.5 plus 3.5 divided by 4, and then again the second coordinate 7 plus 5 plus 5 plus 4.5. So I get this as 4.12, 5.38. So now you see that in second iteration my mean has shifted. In the first iteration my mean was at 1, 1 and 5, 7, which I assumed, and now the mean has shifted because the participant individual data points will now determine the new centroid by calculating the average Euclidean distance. So this has shifted to 1.83 somewhere and 2 somewhere here, 1.83, I'm sorry, somewhere here, or this is calculated 1, 2, 3, 4, somewhere 4 and 5, somewhere here. So my new centroids have shifted here. Now I need to repeat these steps for the new centroid. So what I'll need to do is I'll need to populate this table again, individual data points, which is 1, 2, 3, 4, 5, 6 and 7, distance from centroid 1, distance from centroid 2, and I again calculate the Euclidean distance, and from centroid 1, point number 1, which is 1, 1, and how far is it from this new centroid. So you can calculate it using Euclidean distance formula, and it comes out to be 1.57. I know these calculations are pretty lengthy, so this is 5.38. This point is pretty far away from this red point, but it is closer to this red, So this is 5.38. Then 2 is pretty close, so it has a distance this, and 0.28, then 2.04 and 78. I've already calculated these, so I'll substitute them quickly. So these are the new values, and now you can see that if I was to make new clusters K1, the new cluster K1 after step number 4, the second iteration, only 1 and 2 will fall in this cluster, because the distance of 1 is closer to cluster 1 as opposed to cluster 2, and cluster 2 will have all the other 3, 4, 5, 6 and 7. Then in step number 5, please understand, we need to calculate new centroids again. And new centroids will again be the 1 by 2, so it will be 1 plus 1.5 and 1 by 2, 1, 2, because so only 2 data points are there, and m2 can be calculated as 1 upon 5, the coordinates of the rest of the data points. And you'll find that the centroids m1, sorry, this is m1, they come out to be 1.25 comma 1.5, and m2 it comes out to be 3.9 comma 5.1. Now again in step number 5, using these new centroids, now you'll see that the centroids again shift to 1.25 and 1.5 somewhere here. In the third step, the centroid has shifted to this new point, and this has gone down to 3.9 and 5.1. so this has not shifted much, so a little downwards. So I can mark this as the third time we've gotten here the centroids. And now we need to calculate the Euclidean distance of each individual data point from these new centroids, and it is again going to be 1, 2, 3, 4, 5, 6 and 7 distance from centroid 1, distance from centroid 2. It will come out to be 0.56, 0.56, 3.05, 6.66, 4.16, 4.78, 3.75, and it is 5.02. So you need to show all these iterations, all these calculations in the examination. Now finally, cluster 1 is composed of data points 1 and 2. Distance is small here, and distance is small on the for the rest of the points for cluster 2. So 3, 4, 5, 6 and 7, they fall into cluster 2. Now you see that this thing in step number 4 and this thing in step number 5 have not changed. The clusters composed of data points 1 and 2 in cluster 1, 3, 4, 5, 6, 7, they fall into cluster 2, and even after the centroid changed, the data points have not changed their positions. And if we find a new cluster point centroid this time around using these data points, it will be the same as these two. So that is where our iterations will stop. That is where the system has gotten its final value, and if we look at this now, data points 1 and 2, they fall into cluster 1, and the rest of the data points, they fall into cluster 2. Had we looked with our intuition, with our naked eyes, we would have classified these two data points into one cluster and rest of them into the other, because these two are closer to the origin on the extreme lower end of the spectrum, and these had higher values, so we would have clustered them into the second cluster. So that is how clustering is done in k-mean clustering. And in this video we have divided the space into 2 clusters. We'll do that in 3 clusters. In the next video we'll see some animations on clustering also. And I hope this tutorial was of help. If you liked the video, give it a thumbs up, consider subscribing to the channel. I'll see you in the next one. Take care. Bye bye.